So we're going to look at the differentiation of implicit functions. And in order to do that, we're going to look at what an explicit function is. And an explicit function is a function in which y can be expressed purely as a single function of x. So y equals 5x plus 2 is an explicit function since y is written in terms of x and y is the subject. An implicit function is referred to as a multiple valued function. It's a function in which y cannot be expressed purely as a single function of x. So for example, if we look at x squared plus y squared equals 49, if we rearrange that and change the subject to y, we get y equals plus or minus the square root of 49 minus x squared. And you can see here we've got two explicit functions. We've got positive the square root of 49 minus x squared and negative the square root of 49 minus x squared as our values of y. Or we could have y squared plus 3xy minus 4x squared equals 0. And this is an implicit function because we cannot rearrange this in terms of y because of that 3xy term in the middle. So to derive an implicit function, we derive each term separately with respect to x. Hence, y derives to dy by dx using the chain rule, and we need the product rule for any xy term. And we're then going to solve for dy by dx by changing the subject to that. So the first example, we're going to find the derivative of y with respect to x for the implicit function y squared minus 3x equals 4x squared. So the first thing we're going to do is we're going to look at that y squared term, and we're going to use the chain rule to differentiate it. So what we're saying is that we want to differentiate with respect to x, y squared. So in order to do that with the chain rule, we're going to say that we're going to differentiate y squared with respect to y, and then we're going to differentiate y with respect to x. So what we're going to end up with is 2y by dy by dx. So now we're going to substitute that back in to our implicit function and differentiate both sides with respect to x. So we're going to get 2y multiplied by dy by dx. The negative 3x is going to differentiate to negative 3, and we're going to make that equal to 8x on the right hand side. The next thing we're going to do is we're going to add 3 to both sides. So that gives us 2y multiplied by dy by dx equals 8x plus 3. And then we're going to divide both sides by 2y in order to isolate our dy by dx. And we're going to end up with 8x plus 3 all over 2y. And that is the derivative of our implicit function. The next example, we want to find the derivative of y with respect to x for the implicit function 3xy plus 5y squared minus x squared equals 2y. So we need to do several things here. We've got that 3xy, so we're going to use the product rule for it. And we've got the 5y squared and the 2y, which we need to use the chain rule for. So let's look at the 3xy first. We're going to let u equal the 3x, and we're going to let v equal the y. So that means u prime is going to equal 3, and v prime is going to equal 1 multiplied by dy by dx, because we're differentiating the y with respect to y, and then differentiating y with respect to x. So u prime v plus v prime u is going to equal 3y plus 3x multiplied by dy by dx. The 5y squared, using the chain rule, is going to give us 10y multiplied by dy by dx. And the 2y, using the chain rule, is going to give us 2 multiplied by dy by dx. And then the only thing that is left to differentiate is that minus x squared, and that's going to give us a minus 2x. So if we substitute all of that into our derivative, so we're differentiating both sides with respect to x, we've got 3y plus 3x dy by dx plus 10y dy by dx minus 2x, and that's going to equal 2 times dy by dx. Now I want to collect all of my dy by dx terms onto the left-hand side and all of my other terms onto the right. So that's going to give me dy by dx, and it's going to be multiplied by 3x plus a 10y, and we're taking away the 2 from the left-hand side. And that's going to equal 2x take away 3y. And then we're going to divide both sides by that 3x plus 10y minus 2, which is going to give us 2x minus 3y all over 3x plus 10y minus 2 as our derivative of y with respect to x for this implicit function. So in the final example, we want to look at finding the equation of the tangent to the curve for the function x squared minus xy equals 4 at x equals 1. Now in order to do this, we need to use our equation of a tangent to the curve, which is y minus b equals m upon x minus a. We know that a equals 1, and we need to work out what our value for b is going to be by finding out what y is going to be for this function. So at x equals 1, we've got x squared minus xy equals 4. If we substitute in 1 squared minus 1 times y equals 4 and rearrange that, we get y equals negative 3. So now we need to work out what the gradient of this implicit function is. So we need to differentiate x squared minus xy equals 4 with respect to x on both sides. So we're going to look at that xy term using the product rule. So we're going to let u equal the x, and we're going to let the v equal the y. So u prime is going to equal 1, and v prime is going to equal dy by dx. So u prime v plus v prime u, substituting those values in, is going to give us 1 times y plus x times dy by dx. So now we're going to substitute that in, and we're going to differentiate the rest of that implicit function. So the x squared is going to give us 2x minus, and we're going to put it in brackets because of that negative, y plus x times dy by dx, and equals 4 differentiates to 0. Now we can get rid of that negative by adding that bracket to both sides. So that gives us y plus x times dy by dx is going to equal 2x. Now we want to take away y from both sides. So we get x times dy by dx equals 2x take away y. And then we're going to divide both sides by x to get dy by dx equals 2x minus y all over x. Now we need to substitute in our x equals 1 and our y equals negative 3 into our new derivative function to get the gradient. So remembering that dy by dx was 2x minus y all over x equaled 1, y equaled negative 3, and so we're going to substitute that in. So m, our gradient, is going to equal 2 times 1 minus negative 3, and that's all over 1, which is going to give us a gradient of 5. Now we can substitute all of our values into our y minus b equals m upon x minus a. So we've got y minus negative 3, which is going to give us y plus 3, equals 5 upon x minus 1. Next thing to do is expand that bracket, so y plus 3 equals 5x minus 5. And then we're going to collect all of our terms onto the left-hand side. So we're going to get y minus 5x plus 8 equals 0. And that's the equation of our tangent to the curve x squared minus xy equals 4 at x equals 1.